Hi, welcome to another installment of Math Basics with Mr. Besh. Today our topic is plane geometry, and this is the last of our three installments, two parallel lines cut by a transversal. First, here's our model. Take a good look at this. There are three lines in this diagram. Two of the lines are parallel. I have them labeled for you in white. They are lines L and M. And the transversal is the line that cuts through diagonally. The transversal is red, and I have this labeled as N. Notice that when you cut through two parallel lines, 8 angles are formed. 4 angles are on line L. They would be A, B, C, and D. And then 4 angles are on line M. They would be E, F, G, and H. As a result, each of these angles take on a different term or vocabulary. And that's what we want to talk about today, the vocabulary about what each of these angles are. Now, first we have corresponding angles. By definition, corresponding angles are two angles on different lines, but in the exact same spot. So they're on two different lines, but in the exact same spot. So if I go back to my model here, and I look at my angles, let's for instance A. Take a look at where A is at. It's on line L. Notice that in the same spot, in the same position as angle A, is angle E, but it's now on line M. These are what are referred to as corresponding angles. Take a look at another example. Angle B. In the exact same spot, in the exact same place, but on two different lines, you got B and F. B and F are corresponding. Corresponding with C now is G. And vice versa, last but not least, corresponding with D, you have H. Now, one thing I want you to know about corresponding angles are congruent angles, meaning they have the same exact value. So in the exact same position, in the exact same spot, but on different lines. The next vocabulary term that we have is interior angles. The word interior comes from being inside, and these are angles between the two parallel lines. If you take a look at our model again, notice that there are 4 angles inside the parallel lines, C, D, E, and F. And then you have 4 angles outside the parallel lines, A and B on top, G and H on the bottom. My interior angles are the angles inside the parallel lines, C, D, E, and F. The key here is interior, meaning inside. The other vocabulary term that pops up here is exterior or outside angles, and these are the 4 angles on the outside of the two parallel lines. So if I go back into my model, I take a look at the 8 angles that are being formed. My exterior angles are A and B, and last but not least, I have G and I have H. These are considered my exterior angles. Now, what I do with the interior and exterior angles is what happens in my next 2 vocabulary terms. We start talking about alternate angles. By definition, now before I get to alternate angles are angles that are congruent and on opposite sides of the transversal. When I define for you alternate interior angles are interior angles on opposite sides of the transversal that are congruent. Sameness, they have the same value. So when I look at this, to be alternate, you have to be on opposite sides of the transversal, or opposite sides of the red line, and you have to be congruent. Now, we wanted to see alternate interior, so all we cared about were C, D, E, and F, the inside angles. Alternate interior angles, example would be like angle C and angle F. Okay, they have the same exact value, they are congruent. 2 other alternate interior angles would be angle D and angle E. The other terms that pop up are alternate exterior angles. They work exactly the same way. Alternate exterior angles are also on opposite sides of the transversal, and they are congruent angles. So when I go to my model, angle A, its opposite exterior, or alternate exterior, is H, A and H. And then when I talk about B, angle B and angle G are alternate exterior angles. Now I want to go back to something real quick. Something very important. My picture. Just to clarify and wrap things up here before we end. My model here, two parallel lines cut by a transversal. You got 8 angles that are formed here. Every angle that's side by side one another adds up to be 180 degrees. If I take angle A and add that to angle B, the sum is 180. If I add angle B plus angle D, it adds up to be 180. If I added angle C and angle D, it makes 180. And last but not least, if I added A and C, it makes 180. The same properties hold for angles E, F, G, and H. Another thing that I want you to notice about the angles, of the 8 angles that are here, 4 of those angles are acute, 4 of those angles are obtuse. All 4 acute angles have exactly the same value. My 4 acute angles are A and D, E and H. You can see that just by looking at my model. If I know angle A was, say, 40 degrees, then D would be 40 degrees, E would be 40 degrees, and H would be 40 degrees. Vice versa, the converse, angles B, C, F, and G are all obtuse. Angle A plus angle B would add up to be 180 degrees. So if I knew what angle B was, by example, if angle B was 120 degrees, then angle C would be 120 degrees, angle F would be 120 degrees, and angle G would be 120 degrees. Remember, you got 8 angles here, but if you're filling in the blanks and the answers, only 2 numbers would be filled in. All the acute angles would have the same value, all the obtuse angles would have the same value, and any acute angle and any obtuse angle added together would make 180 degrees. This was my model, two parallel lines cut by a transversal. I hope you found this both helpful and informative.